Okay, we are going to look at something new, something exciting, and you can think of this as introducing a really big concept. Okay, that's what we're doing here. So before I actually, give away what's going on here, I want you to think about how we solve linear equations like the one I have listed here, 2x plus 5 equals 11. Now, you may think about it slightly differently than the way I think about it, but probably we have similar thoughts and you may not actually be able to communicate what your thoughts are very easily. That's also fine. When I look at this, I go, okay, I need to get x by itself, and so I'm going to move the things that are around x by undoing them or using opposite operations, however you want to think about it. And there's an order I do that. I will mess with the plus 5 before I mess with the 2, because if I'm undoing what is happening to x, the plus 5 is what would happen after the 2x. So I'm undoing, so it's going backwards in the order of things. So I'm going to do a minus 5 to both sides and get 2x equals 6. Then we divide by the 2 in front, and we get x equals 3. Okay, so our goal thus far has been get x by itself. And then last week we added a little extra step to our lives where we said, okay, instead of it being x, what if it's x squared? And we said, okay, we can still solve for x by first solving for x squared. And so we do that in the same way that I just did the previous one. I'm going to minus 1 and get 5x squared equals 45. I'm going to divide by 5 and get x squared equals 9. And then it's at this point that we have something different, because this isn't x by itself. This is x squared. If that was our goal, was to find x squared, then yeah, we'd be done. But typically that's not our goal. Our goal is to actually find x. So we do one more thing. We say, let me take the square root, because the square root of x squared is just x, and the square root of 9 is 3. But because of us solving this equation, we have to remember that it's a plus or a minus 3, or you could write it separately as 3 and negative 3. Okay? So that's what we've done up to this point. And now we're going to talk about how do I solve a quadratic equation that looks like this, 2x squared plus 3x minus 5 equals 0. Because it's nice when we don't have an x term, which is what we have dealt with thus far, but that's not always going to be the case. And in fact, if we're trying to relate this to real life stuff and we're talking about physics, the middle part is like your starting velocity of whatever you're throwing or projecting somewhere. So kind of important that we know how to work with this. And so you may have like some ideas about how you'd get x by itself. You might try, adding 5 over, because that's worked well for us in the past. And then get here and go. You might actually go, well, can't I just divide everything by x? Isn't that helpful? And not as helpful as we would like, because dividing by x makes it 2x plus 3 equals 5 over x. So we've just introduced a different issue into our equation that we don't know how to deal with. So that's not going to work. And aside from that, if we did know how to do this, we still wouldn't divide everything by x, because when we divide everything by x in an equation, it makes us accidentally lose an answer, or it can make us accidentally lose an answer. So we don't divide by x in general. So that's not it. What else could we try? Maybe you're thinking of factoring, that maybe we could split this up into the original. Maybe we could split that up into 2 parentheses. But, how is that helpful? Or maybe the way I have it written down here, what if I take the x out and that gives me 2x plus 3? Well, is that helpful? can I figure out what times 2 times the same thing plus 3, that together that makes 5? Well, that sounds really complicated. I personally don't want to do that. So you can hopefully imagine, based on just what I've talked through so far, that it's not as simple of a problem as we might like. So what we have is called the quadratic formula. So, when we're in science class especially, and there's a formula, we may not realize it, but that's actually really nice that we don't have to figure something out. Someone's already figured it out, and we get to just use a formula. The quadratic formula is kind of like that. This is a formula that has been around for a while, and we know it works. It will let you solve any quadratic equation ever, and so it's kind of a big deal. Now, it's a little bit intimidating when you look at it at first. So I'm going to write it here to the side, and you should write it down as well, and pay attention to, writing it exactly how I write it. So first, we need to have an equation that we can think of as being ax squared plus bx plus c equals 0. This means that it's in standard form because it's got the x squared first, then x, then the number. A, b, and c would be numbers, and b and c can actually even be 0, which means we wouldn't have those terms, but we have to have a, or it's not a quadratic equation. A could be 1, though, and that would be fine. If I'm looking at this example that we're going to go through, what it means is, even though these are k's instead of x's, so my bad, it means that the number in front of that's a part of our squared term is a. So a is 10. The number in front of our x term or k term here is b. So b is -4. And the number that's just right here to the side is c. And we want everything on the left side of our equation. We want it to be in order. And if it's in order like this, then it's alphabetical. A is the first number, B is the second number, C is the third number. We're not going to worry about the 0 on this other side. The 0 on the other side is just what allows us to do this. So that is like a first thing. We need to have a way of defining what we're going to put into the formula. This is our way of defining it. The formula itself is, buckle up. No, that's not the formula. X equals, you might not want to start writing it down until I'm done. X equals -b plus or minus square root of b squared minus 4ac all over 2a. I would almost be willing to bet a lot of money that this is the most complicated formula that you've seen at this point in your life. And I said almost because I'm sure that someone out there is going to be like, no, I've seen something more complicated. Good for you. But this is on the complicated side. We've got 3 different things we're plugging in, A, B, and C. We've got a plus or minus sign, which actually is how we end up with 2 answers from this formula, is by at the end saying, okay, I have this plus this over this, and then this minus this over this. I feel like I should probably be like here's a number, here's a number, here's a number, and there's a plus, and then here's a number minus, here's a number, here's a number. So at some point we'll be able to go, okay, I'm going to separate this out into my 2 answers. One has a plus, one has a minus. Because remember, quadratic equations are supposed to have 2 answers. So let's walk through one of these, and just so you know, I have a couple different videos of ways to make it easier to memorize this formula that I will definitely share with you and you can check out. So, that's a great idea. So even though this is k's instead of x's, we can still use the quadratic formula in case that throws you off. We would put k equals if we're trying to be like really, really correct about this. I often forget to change the variable when using the quadratic formula because it makes it so, it's so nice when it's x equals. there's a way you can sing the quadratic formula that is to the tune of Pop Goes the Weasel. So that's part of why it's hard not to say x equals, because it's part of the song. Go check out my version of the quadratic formula with Pop Goes the Weasel. So let's see. In this case, we have b is -4. My formula says negative b. So what I need to do is think, what is negative b? Okay, what is that? -4. Well, two negatives give us a positive. So that's one of the initial things we'll be able to do on our simplifying of this is we'll be able to either say, okay, there's only a single negative, so we're good, or there's a double negative, so let's change it to positive. Next comes the plus or minus symbol, which, you know, probably still seems at least a little weird. Then we have this big square root. Okay, and so under the square root, we have b squared. It is important that you understand that when we square something like this in a formula, we're squaring that entire number. So when I do b squared and b is -4, I am squaring -4, which is -4 times -4, which is positive 16. Okay, if you don't put the parentheses around it, you may still end up doing it correctly because you know what you meant, but if you type this in the calculator this way instead of with the parentheses, it's going to tell you that that's -16, and that's not correct. So you'll see me put parentheses around whatever b is to help us remember that, you know, that's the case, that it's being squared. Okay, next comes -4ac. Now, there is multiplication happening between these. Also, the 4 and the 2 in this formula are just always 4 and 2. There's nothing that changes that. It's what makes this all work out, is having a 4 here where we're at, and then a 2 on the bottom in front of a. So I'm going to do -4 times a, which is 10, times c, which is -5. Whew, that's a lot. We're going to come back to that. On the bottom is 2 times a, so 2 times 10. That is also a relatively easy part of this to simplify. That on the bottom, we're always going to have 2 times something, so we can write it. You can even write it like on your first step if you want to. You can actually, this could be your first step because you could say, okay, well, I know a negative and a negative is going to make a positive, so that's +4. I know 2 times 10 is going to be 20, so you could start here. You don't have to start back at this step unless you want or need to. Now we need to figure out this number that's under the square root, and we're going to figure it out without actually taking the square root yet, because what we're going to end up doing is trying to simplify the square root if it's not a perfect square. So -4 squared is 16. This is one of the places that people mess up, because we're multiplying 3 numbers together, and at least one of the numbers every single time is going to be negative, because this is -4 in our formula. So we have to think, okay, if I do -4 times 10 times -5, well, first off, 2 negatives make a positive. And then we need to actually multiply these numbers together. 4 times 10 is 40. 40 times 5 is 200. So we have 16 plus 200 under our square root, which we can add that together and get 216. Now, that's what goes here. If we can, we're going to simplify this square root like what we learned how to do, like just last week probably, which is look for things inside of 216 that are perfect squares. I'm pretty confident that 4 goes in 54 times. For 54, that goes in 9 and 6. So depending on which way you prefer to think about it, you can either say, okay, here's my here's my square roots, and I can figure out what it is. Or you can go further on each of these, right? And then we're looking for all of our pairs of numbers. Those get to go out, and the singles have to stay in, whichever way. But simplifying square root of 216 should be 2 times 3 on the outside from here and here. 2 times 3 on the outside, which is 6. And then the 6 over here that doesn't have a perfect square because it's 2 and 3 is going to stay square root of 6. It's kind of a satisfying number, 6 square roots of 6. Maybe not to you, but to me. Now, this probably looks like a thing that should not be an answer. And it's not quite the answer, but we're actually really close. There are things we could do to this. We can separate it out into 2 different things, which we will in a second. We could actually also separate it into 2 different fractions. If that made it seem like it was easier, we could do that. And one reason to do that, or at least to think about it like that, is I can simplify these fractions, but I have to be able to simplify. I want to be able to simplify both of them, or I'm not going to simplify. So we're going to look at this number, and this number and say, what can I divide all of those by? This doesn't matter because it's protected by the square root. 4, 6, and 20 all divide by 2, so we're going to divide each of these by 2, just like we're simplifying a really complicated fraction. So that gives us 2 plus or minus 3 square roots of 6 over 10. You can leave that as your answer. Alternatively, we could separate it out into 2 different fractions, one with a plus, one with a minus. If you needed to get on your calculator and find a decimal answer to this, you would need to put it in separately. Your calculator doesn't do a plus or minus sign, to the best of my knowledge. So we'd separate them and we'd say, okay, what does this equal? What does this equal? And we'd get decimals if that's what we needed. I'm going to want you to practice simplifying as opposed to putting it in your calculator and getting decimals, just a FYI. This probably seems like a really long process, and it is, but it will get better as you go along. So you got that going for you. Like every time you do one of these, hopefully you'll need less and less help, and it'll go a little bit faster each time until, by the end of the year, this may not actually seem so bad. That's the hope. Or maybe next year in geometry or in algebra 2, you'll be like, I miss the good old days of the quadratic formula. Maybe, maybe not. Okay, thanks for watching.